Good day, everybody. Today we're going to finish up with long division and dealing with exponents. Y'all, today I'm going completely blank here. No typing, no nothing. So I'm gonna get all close and personal on today's lesson. So look, we've been dealing with long division for a good minute now. And I mean, you guys like, ugh, I can't take this no more. And I feel you. So today, we're finally gonna get through it. So I'm gonna set us up with the division problem that we're pretty familiar with. Don't forget this x plus 3 is the divisor. The x squared plus 5x plus 6 is your dividend. Now, we're gonna go ahead and get through with all of this right quick. So, we know for a fact we multiply. We divide x squared divided by x gives me x. You know that. But we know that x times x is s squared. X times 3 is 3x. But we know for a fact, after we get through there, we gotta make it all negative, right? So let's do that. Negative sign here, this positive becomes a negative here. Alright, so the x squares cancel out. Guys, 5 minus 3 is 2. And because I have an x, I bring that there and break it down. Now, I know in the first step I did, the first process rather, I didn't show all the work. It's only because by now you guys should know how I did it. You know I went x squared divided by x equals x, x. And then I set up to do my multiplication. I get x squared plus 3x. And then I know when I subtract, I have to bring this down. Turn my signs around. So we know those things already. So guess what? No need for me to write all that because we've been doing this for so long. So I'm just speeding it up. If you still need, well, I could be nice. I'm going to go through this process, but I'm only going to do it maybe one more time after this. And then through the other long division problems, I'm going to do it. Because by now you guys should have this down to a science. Alright, let's do this. Alright. We have 2x divided by x. That's just 2, right? Alright. 2 times x plus 3. 2x plus 6. Don't forget change your signs. Don't forget this is your quotient, so you gotta bring this here in your quotient piece. So let's go ahead and do this. And bring this over there. So that out goes to 0. So what if I could show you another way of dealing with that? Let me show you another way of dealing with that same problem. But in order to do it this method that I'm going to show you, you have to be sure to know how to factor. So let's do it right fast. X squared plus 5x plus 6 over x plus 3. Let's speed this up, shall we? Well, let's focus on the numerator. We could factor this. So what two numbers will you multiply together gives you 6? But those same two numbers, add them together, gotta give you 5. Excellent. 2 times 3 is 6. 2 plus 3 equals 5. So again, I'm working on the numerator. You take those two factors that we worked out, and guess what? X plus 2 over x plus 3 over x plus 3. Now you ready for the magic to happen? Guess what suddenly disappears? You guessed it, x plus 3 disappears. And we're left with x plus 2 for the final answer. Same method as we did for the long division method, but let's ask a question. How we was able to cancel out the x plus 3? Well, remember, everything have an exponent of 1. So the x plus 3 in the parentheses has an exponent of 1, always. The x plus 2 have an exponent of 1 too. But because x plus 3 being the same base, you could subtract it. So it goes x plus 3, 1 minus 1, equals x plus 3 to the power 0, which gives you 1. Easy. Alright, let's do one more example. Then we can move on. Alright. What about x squared plus 8x plus 15 over x plus 3? Another way of looking at this kind of problem, let's look at your denominator. Your denominator, x plus 3, tells you something. It tells you that x plus 3 is also going to be a factor here because you know that x plus 3 will cancel out. So what two numbers will you multiply together gives you 15, but you got one factor already of 3, so 3 times blank gives you 15. If you are stuck at this part, replay what I just said. Again, in the denominator, you got x plus 3, right? Now, what two factors multiplied together gives you 15? The denominator gives you a hint already of one of them. So you know one of them is 3, so 3 times blank gives you 15. 5. So x squared plus, well, x plus 3, x plus 5 over x plus 3. Guess what happens? Cancels out again. Now you're left with x plus 5. Just like that. If we do the long division method, we're going to get x plus 5 as we did the previous problem. So if you're stuck, go back to the previous problem I just did. That's going to come in handy. Now, I'm erasing. And again, I just didn't feel like typing because I want to kind of make this up close and personal for you guys. Alright. So let's deal with these exponents because the thing that we've been dealing with since day one, exponents, characteristics of functions, and polynomials. So let's remind ourselves of what it means for a function to be a polynomial. So that means that the exponent, because we've been dealing with the exponents, have to be greater than or equal to 0. So that means if you're dealing with an exponent, you're dealing with a function like f of x equals x to the power of 0. That's an exponent. X to 1 is an exponent too. X2 x to the nth power. Nth means some number. It could be n to the 99999999999 power. Guess what? It's a polynomial. For what does it mean for something to be not a polynomial? anything with a root, anything with a negative power, -1, x to the negative nth. It's a cannot be a polynomial because anything with a negative number or a root or with a fraction power, all those cannot be polynomials. And let's not forget this guy. So I'm going to ask you a trick question. So why can this not be a polynomial? 1 over x. 1 over x is similar to one of these exponent rules. You're going to have to look that up and find that out. Good luck though. Alright. All this is going to come into play. Well, been coming into play what we've been dealing with. Alright. Let's speed this up because I don't got all evening. I got things to do. Alright. 4 to the power of 0. I'm just giving you an example. That's 1. 4 to the first power is 4. We could say that. 4 to the second power is 16. 4 to the third power is 64. Now, I'm not saying 4 times 3. No. Be careful of that. 4 times 4 times 4. That's 4 to the power of 3. So remember, exponent is repeated multiplication. Alright? I'll do a few more, then we're going to speed up. Alright? 5 to the power of 3 is saying 5 times 5 times 5. 2 to the power of 3 is saying 2 times 2 times 2. Alright? Let's proceed. You got something that looks like this. Using all the law of exponents that we just did. So 2 to what power gives you 4? Well, the exponent's right there. So you got to rewrite this x plus 2, x minus 2, because you got positive, negative. And then x minus 2 in the denominator. Cancel it out. Guess what? X plus 2. Let's do another example. X squared minus 9 over x minus 3. Same thing. X, you see 9, you see 3. So how many 3 does it take to give me 9? Well, the exponent tells you 2. So x plus 3, x minus 3. Because you want to start positive and negative. Over x minus 3. Your x minus 3 cancel, you get x plus 3. Alright, let's do one more of these examples, move on. Alright. X to the power of 3 minus 27 over x minus 3. So, let me erase this before you guys start tripping on me and thinking it's something that's not. Question. So if I had 3 and 27, how many 3's does it take to get to 27? Well, the exponent right there tells you 3. So guess what? X plus 3, x minus 3, x plus 3 over x minus 3. Guess what's going to cancel out? X minus 3, so you're left with x plus 3 and x plus 3, which you could say x plus 3 squared. That's no way of saying that. All right, we're almost done here. I think you guys caught on. If you're stuck, just replay this video because that's the whole point of this video is for you guys to rewatch and replay. So please don't go forth knowing that you didn't understand. Replay the stuff. Let's get through it. So you got something that looks like this. I'm going to do one of these because I want you to get the habit of replaying stuff over and over again to get it, because that's the whole point of videos. So you don't never want to move on if you don't understand something. Try this problem. Which method I have to use? I gotta use long division. I can't factor this out. There's no tricks I could do. Those tricks we did doesn't work to this. There's nothing in common to cancel or factor out. And again, I am moving fast like I'm Busta Rhymes, but it's been a day. 6x cubed minus x squared minus 5x plus 4. So let's go ahead and get through this already. Y'all gotta forgive me about my handwriting. No way I could do this with speed. Going through our process again. 6x cubed divided by 3x. 2x squared. Okay, so we know that 2 times 3 is 6x. 2 times 2 is 4x. So you guys know that I'm moving quick because you guys know what's up. But I gotta change my signs here for the 4 because it started off with positive 4, negative 4. So it's just, you guys know the process, so just go back and check through it. So I'm left with 3x squared minus 5x plus 4. And again, guys, I encourage you to replay this stuff over and over. It's going to make more sense. Rushing through the stuff is never going to help you. You're going to fail this class. All right, let's try this again. So divide this 3x squared divided by 3x. That's going to just be x. 3 times x, 3x squared. And then x times negative 2, negative 2x. We got to change our signs. We know that. That cancels out. This negative 3x plus 4. We almost done, y'all. Again, I'm sorry for going off quite fast like I'm Busta Rhymes, but I need for you guys to understand. All right, negative 3x divided by 3x is just negative 1. So negative 1 times negative 1 times 3 is negative 3x. Negative 1 times a negative 2 is positive 2. So if I change my signs, things cancel away. 4 minus 2 is 2. So you have a remainder. Sometimes when you do these division problems, you're going to have a remainder. So again, I know this was quick and lightning quick, in fact, but it's best for you guys to go back and replay these parts because I promise you it's going to make a lot of sense. All right, y'all, that's pretty much just it. I'll leave you something for food for thought. And then that's pretty much all I got to do. Again, replay this part if you need to further understand. Again, repeat all the division process that we did so far. So this is what I want you guys to try on your own. Alright, try that out on your own. And we leave it just that. Unfortunately, I do have to leave you with one example or something else. Because I got to get this covered. Alright guys, here goes something. B cubed minus 50 a squared minus b all 10 ab. Alright, what do they all have in common here? Well, they all have a 10ab in common. So for this part, divide and conquer, y'all. That's all you have to do up in here. So let's go ahead and do it, y'all. Alright, 70 divided by 10 is what? 70. A divided by A is just 1. B cubed divided by B is B squared. Alright, so that's one piece. Alright, let's put this other piece together. 50 AB squared B divided by 10 AB. I'm left with what? 50 divided by 10 is 5. A squared divided by A is just A. B divided by B is just 1. So 7B squared minus 5A. How to solve this problem? Again, review the video if you didn't catch it. Because sometimes you may need to hear the parts over and over again. Pause too if you need to. Alright, let's go ahead and wrap this up. Now I want you to try this one out on your own, and you do this on your own. Pause it, find out, and I am out of here. Good evening, good night, and have yourselves a good evening. Best of luck to you on my quiz next week. Deuces.